8.5c linear equations. It sounds crazy, but it's not. So just to review these things, because linear inequalities are going to be included in that too, it's really important to know how to say the signs out loud. I know it could be annoying me going over this constantly, but it's a must, and you have to be able to say them. And just know that whenever you're solving equations, if you multiply or divide by a negative number, you have to flip the sign. That's the only other rule whenever you're solving inequalities. So let's start with some simple spots on this. There's several parts. One of them is called b. B, why it's called b? Because it can't be called y, because y is already y. So they put b in there to make it confusing. B is, of course, the y-intercept, because whenever you're talking about a y-intercept, why wouldn't you use the letter b? Yeah, I don't have a reason either. I can't even make one up. Bad idea. How about that? So know that b is a y-intercept. If you think about interceptions in football, regardless if you like football or not, I played 1 year, so it's not like I'm some sort of aficionado. A pass can be thrown from the quarterback to a receiver. Someone can cut in front of that receiver and intercept the ball. That means that there's a line that went through the line that the quarterback was throwing to the receiver. Whenever that person catches the ball, it's called an interception. So if we had a line starting here and ending here, then this would be the QB, the quarterback, and this would be the wide receiver, okay? Throws the ball, you'd have an interception at 3. So that's what B is. So if we go and we look at an equation, which is set up in the form of y equals mx plus b, which is the standard form for slope-intercept. This is called slope. This is called the intercept. This intercept is going to be where your bread and butter is at. Know where the intercept is, know what the intercept means, because that is your starting point. That is the easiest way to do this. So you can see how this says +1 for your y-intercept. So on the y-axis, I'm going to go plot a point at +1. Now we can already see that the coordinates to this are 0, 1. Now another way to find a y-intercept is if your x value is 0. Anytime you have a y-intercept, x will always be 0. You can see because it's always going to be on the y-axis. Whether it be positive or negative, it'll always be the y-coordinate because it's a y-intercept. All right. Anytime that we have a number next to a variable in the slope-intercept form, which is what we're looking at, y equals mx plus b, m is going to be your slope. Slope is how slanty a line is. Now imagine a mountain that looks like this, and you're a dude that's standing up here, and you're like, okay, let's go down this mountain here, okay? Whoa, geez. You're going to go that way. That is extremely slopey, okay? Extremely slopey. You're like, that's too slopey. That's, I'm going to slope intercept my face into a tree when I get down there. So if we're talking about slope and we wanted to go like this, you can see that's not as slanty. This is a slope and this is a slope. This is a positive slope. This is a negative slope. So going up from left to right is positive. It's increasing. As you go down from left to right, it is decreasing. That would be a negative slope. The example in this one is a positive slope. Okay, you can see here it says 2. Oh, like all the colors to choose, I keep picking the same one. So this is where your understanding of rational numbers comes in, because right now 2 is a whole number, but you can write any whole number because it's a rational number. You can write it as a fraction by putting a 1 underneath it. 2 divided by 1 is still 2, all right? So what this does is it tells you how far to go up and over. So it's a positive 2, so you're going to go 2 up. It's a positive 1, so you're going to go 1 right. And where do you start that? That is going to start at your y-intercept, which is why we plotted this +1. Check this out. Up 2 over 1. Plot the point. Up 2 over 1, plot the point. Up 2 over 1, plot the point. You can see how this is making a line because this is a linear equation. In the word linear, the first four letters are line. So if you wanted to take the complete opposite of this, because negative 2 divided by negative 1 is still positive 2, you would still have a slope of positive 2, which would reverse this process. Bloop, bloop, left 1. So we're going down 2 and then the left 1, the complete opposite. Down 2, left 1. You can still see how it keeps the same bearing on this line, okay? So right now what we have is a line crossing through 1 on the y-axis and has a slope of 2 over 1, or just 2. Now, the thing I want to point out also, there's a whole bunch of stuff I'm pointing out here. There's going to be a couple things that we focus on in the problems to come. So whenever you're looking at your y-intercept and you see your x values are counting by 1 incrementally, 1, 0, 1, 2, 3 instead of 0, 2, 4, 6 or 3, 6, 9 or whatever, then you can use your slope and count by 2's. Watch this. So over 1 up 3, over 2 up 5, over 3 up 7. Look at this. Plus 2, just like the slope. Plus 2, just like the slope. Plus 2, just like the slope. And where did we start? B, your y-intercept, positive 1. So there are a whole bunch of patterns tying into this. And right now, the thing I want to focus on is identifying that equation using the y-intercept and using the slope to your advantage. Eventually, we're going to get into four corners of all of this, where you're going to have a equation representation, you're going to have a graph, you're going to have the bits and pieces of identifying the piece of the equation, and you're going to have a table. And you should be able to work from all four of those to recreate the other three. So let's get into what we're focusing on. So I just went over all this stuff. The thing I didn't go over was y was your output value. Because whenever you put an x value in, for example, if we put 0 in for x, we would have 2 times 0, and then we add 1. 2 times 0 is 0 plus 1 is 1. That is why we have 1 right there. Our y value, the output. So when you put a number in, you're going to get a number out, and those are called your coordinates. And whenever you start making sense of this stuff, you'll start seeing the algebraic relationship between two ideas, like the amount of money you make when you sell an amount of tires or whatever. If you were to start selling airheads on the black market at school in private for 50 cents a piece, then you'd be able to extrapolate that information and understand how much money you'd make if you sold 50. You could even make a graph. And you could even make a graph where you'd understand how much you spent and how many you're going to need to sell before you break even. The joys of algebra. All right, so I just want to show you this a couple more times, and if you want to like pause the video and demo this yourself, by all means. And here's the way you could do that on a piece of paper. You just draw a simple coordinate grid, and you'd be identifying the y-intercept, and you'd just go like, okay, that's at positive 3. You're just identifying it's above 0. Good, it's positive, it's good. And then it's going to be a negative slope, down 3, right 1. Down 3, right 1. Down 3, right 1. Down 3, right 1. And this is going to be similar to the assignment that I'm giving you, just so you can identify positive, negative lines, slope, and y-intercept. That is what you'd be looking at if you were to just sketch it. Now, if you have a printer or anything like that, you can find a coordinate grid and you can print this off, and then you can use this over and over again. So just to reemphasize, we know that the plus part is the y-intercept. That's always when x is 0. I'm just going to go ahead and plot that at positive 3. We know that this is going to be our slope, the rise over the run. So how far up and down over how far left and right. And that's going to be the opposite of what everything you're used to, because we're using an equation to work backwards. Just like when we're solving equations, we had to work backwards by doing inverse operations. We're doing something very similar here, and we'll get into that eventually, but not today. So to keep this an integer, but to also make it a rational number, we can always put a 1 underneath it. Negative 3 divided by 1 is still negative 3. So we can see that this is going to be decreasing by 3 and going to the right by 1. 1, 2, 3, right 1. You can see how it'll start matching up to the one over on the side here. Down 1, 2, 3 over 1. Down 1, 2, 3 over 1. And then we can reverse that process, positive 3 over negative 1. 1, 2, 3 over 1. You can see how it's making a line. And you'll know if you're given a set of coordinates, if you're given this part and you plot them, if it's in a line, then you know you have a linear equation. If they're all over the place and you're sitting there going like, I got to connect this, then you know you have a problem. You should probably go back and take a look. So what's good about this is to check your work, all you have to do is look at it. Let's just go ahead and look at the coordinate plane and verify these coordinates. Okay, so over 1, up and down 0. Over 2, down 3. Over 3, down 6. You can see here that the pattern continues. Negative 3, negative 3, negative 3. X was counting by 1, and so we have a slope of negative 3 over 1. So you can see how we can go from a table to create the slope and then also look at this to get the y-intercept and write the equation. So what we're focusing on is being able to use the equation to make the line. If you feel like pausing it and you want to do a demo on this, perfectly fine. Here's the next one. The reason I include this is not because it's complicated, but more for the reason of I don't see a number in front of x, but how many x's do you see? You see 1. So just know that whenever there is just a lone variable, there's always an invisible coefficient. There's also be called a number in front of the variable, and that would always be 1. The place to start would be your y-intercept at negative 3. And we know that's when x is 0, so I'm just going to go ahead and put it right here. Now, if you wanted to get risky, now I would not advise this because you have to double check this because you're going to be plotting it and as well as doing the coordinates. You could just count by 1. You know this is going to be increasing by 1. Let's see if we're right. Okay. So we have a slope of up 1 over 1. Okay, super simple. You can see that whenever you have a slope of 1, this is like the default line of a slope of positive 1. A slope of negative 1 would be its inverse, and it would be going, like this way. But we're not doing that right now, so I just want to keep on pointing things out as they come up. So we have a positive line with a slope of 1 crossing through at negative 3. That is 1x minus 3. Let's see if these coordinates match up. So 0, negative 3. 1, negative 2, 1, negative 2, 2, negative 1, and 3, 0. Cool. Now, just know that to make a line, all you need is 2 points. And the reason I do 4 is because I want to make sure that everything is right. There are off chances where you can plug a number in and it works, and it's actually not a line. I always go above and beyond when I'm checking my stuff. All right, so here's the inverse of the one we just did. And inverse just means opposite. I'm sure you know that. Start with your y-intercept. It's almost like when they give you the equation, it's just like, you serious, really? It's like, yeah, I'm serious. It's like, well, all right. So negative 1x. So we know that we're going to have a negative line, so it's going to be going this way. So it's going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1. Or the opposite, up 1, left 1, up 1, left 1, up 1, left 1. And then you can see the negative line, and you can see that it's going up and down by 1. So just to get risky, we already know that the y-intercept is negative 3. We know it's going to be decreasing by 1. Okay, so look at that. Minus 1, minus 1, minus 1. The change in y over the change in x, which is exactly what we had over here. Negative 1 over 1, negative 1 over 1. Starting at negative 3. Boop. Check, 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 check. Awesome. Okay, so negative 2 plus 1. And you might sit there and go like, all right, I got this already. But honestly, there's just going to be some little things here and there that it doesn't hurt to see it again. And it's always good to have more examples than less. So starting with the y-intercept, positive 1, we're going to turn this 2 into a fraction. So 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and its opposite. And you can see we have a very thorough line going from end to end. Okay, that's the straightest line I can draw. Don't hate me. So you can see that our y-intercept is at positive 1. We already know that that's going to be right there. Over 1 up 3, over 2 up 5, over 3 up 7. Okay, you can see that that is following our plus 2 starting at positive 1. And this is something you may have done in previous grades called sequencing, where you have a set of numbers following a pattern and then you have to write the rule for it. This is what you were doing that for. You were doing it for algebra. 2 over 1, 2 over 1 starting at positive 1. Boom. So, you know, like you're sitting there going, wow, like, you got anything else? And it's like, I kind of do. What if you're given a fraction? You know, what happens then? What if you have a fraction as your slope? Well, you know, it sounds confusing, maybe, but it's actually even easier because you have less to do. You don't even have to put a number on the bottom because it's already there for you. So 1/2 x plus 1, you still do the same thing. It's just you're going to have a line that's not as slanty because it's going, it's a reciprocal of what we were doing before. So instead of increasing by 2 and over 1, it's going to be increasing by 1 and go over 2. So it's going to make it less slanty. It's going to get flatter. So know that anything that's greater than a slope of 1, so like 1.5 x, is going to be slantier than anything that's less than 1, like 1/2 x. So I'll always start with your y-intercept. That's going to be at positive 1. And you're going to go up 1 over 2, up 1 over 2, up 1 over 2. And you can see how it's already less slanty. Okay. So Jeff Bezos, whenever he is making money on Amazon, his slope is significantly slanty. It's like that when I drew that skier on top of that mountain that was going to slam his face into a y-intercept tree. That's the kind of money that dude makes. That's a super slanty thing, all right? So this is more like a teacher slant. This is the kind of money we make over time. So if you wanted to, you could say it's increasing by 1/2, and I want to show you what that looks like, because this would be 1.5, so watch. Over 1, and you can see how it's crossing through at 1.5 on the y-axis. Okay, and then 2, 2, still increased by 1/2, and then 3, 2.5. That's why sometimes it pays to, you know, like plot your whole numbers, because you know exactly where they're going, and then everything else will fall in between. See, look, bloop, bloop, because if it's a straight line, it should fall in between. So fraction's not really a big deal. It's just it can get kind of tricky if you have coordinates and you're trying to plot them and then find out what the slope is and stuff. But whenever we get to converting tables into equations and then plotting the equation, it's not going to be anything crazy. It's just another thing to learn. So you're starting with your y-intercept, positive 4. You see we have a negative slope. It's going down 2 and over 3. So already know that's going to be 4. So down 2 over 3, down 2 over 3, up 2, left 3. You can see how that continues the line. No problem. We started at our y-intercept, which was 0, 4. So this is going to be decreasing by 2/3. So this is why I wanted to bring this up, because when you're filling in a table, this is going to look weird. So if you went from 0, 4 and you just check the coordinates at the first whole number, which would be at 3, x is 3, you'd see 2. Okay. So now we should be decreasing by 2/3 in between 2 and 4. So it should be 3 1/3. and then decreasing by 2/3, so 3, and then 2 and 2/3, and then 2. So just so we can be clear, I'm going to make this slope here just by using the whole numbers. So we can see it's decreasing by 2. We can see that that went up by 3, and that's how you get your slope. Y over x, negative 2 over 3, negative 2 over 3. And it started at positive 4. Okay. So here is an example of the work you're going to be given, and this is what I want you to focus on. Let's say you can print it, all right? Then I want you to put it exactly as it is. I'm going to put it exactly as it is, then next to it I'm going to do a little sketch. All I'm asking for is a sketch. And you're going to identify 2 parts after the sketch. So you're going to plot at the y-intercept, and you're going to go down 4 over 3. 1, 2, 3, 4, 1, 2, 3. And you're going to do its inverse. You're going to go up 4, left 3. 1, 2, 3, 4, 1, 2, 3. And you can see how you have a negative sloped line crossing through at negative 1. So that would be your slope, which would be down 4 over 3, and your y-intercept, which was negative 1. There is that graph done and the 2 things I need you to identify. Let's say you don't have a printer, okay? This is all I'm asking you to do. Identify that your slope is below 0, and then estimate 1, 2, 3, 4 over 3. Down 4 over 3. And show me that you have a negative slope, okay? Best estimate, need sketches, and got to have those 2 items right there, all right? Now, the next thing that's going to come up is us working from tables to create equations, or using a graph that's already plotted to make an equation and or a table. These things all intertwine, and they're all the same language. They're just written with different symbols. So let's give this a go and see how you do. And if it's really easy, I'll throw more in for the next round.